Alright, so now I'm going to explain you about one of the question that is commonly asked as an example for pH-pKa relation with an amino acid. I'll read out the question for you. A drug contains one ionizable group, a weak base with the pKa 9.0. The drug enters cells via free diffusion through the membrane in its uncharged form. This will occur most readily at which of the following pH values? Now the options given are option A 3.5 pH, option B 5.5, option C 7 and option D 7.6, option E 9.2. And here is the question that I have just read out. Now let me explain what is the answer for this question. Now the drug which has got ionizable group, and that is they are given it as amino group. So I am writing a drug here and it has got only one ionizable group, and that is amino group NH3 plus, and pKa of this is 9. Now the question is at what pH range or at what pH value this particular drug will enter into cell using free diffusion. Know that cell means any molecule to get into a cell by free diffusion, it has to be a non-polar molecule, right? Now your drug is a polar one. It has got amino group NH3 plus. It has a positive charge. Obviously in this form, it is not going to get into cell by free diffusion, but it can get into cell by using a channel. But that's not the question. The question is at what pH it will get into a cell using free diffusion. Now how to make this particular drug non-polar? You just need to take out this proton, one of the proton here. So it means you really need to deprotonate this particular drug. So deprotonation has to be done. H plus has to be removed. Once you remove H plus, so this drug will become like this. It will be NH2, and that's a non-polar. This has to be done. So it means deprotonation has to occur here. Now you know the pH-pKa relation. So let me reiterate, I have a video on pH-pKa relation. You can see the video as the link that is appearing right now on the right upper corner. Okay. Now let me just quickly revise that. When pH is less than pKa, so there will be protonation occurring. Protonation occurs. When pH is greater than pKa, deprotonation occurs. When pH equals to pKa, there will be 50% and 50%. 50% protonation and 50% deprotonation. Now we want deprotonation to occur to this drug so that it becomes non-polar and uses cell free diffusion to get into the cell. So in order to make deprotonation, we know the pKa of this drug here, amino group, is 9. It means pH should be more than pKa for deprotonation. So it means what should be the pH where this drug will undergo deprotonation? So obviously pH should be more than 9. pH should be more than 9. It means when the pH is more than 9, say consider 9.2. 9.2, that's the option E in the question, 9.2. When the pH is 9.2, pH equals 9.2 and pKa is 9. So you are dealing with pH more than pKa. It means your drug will undergo deprotonation. It will get into NH2 form, and that's a non-polar molecule. So it will enter into cell with free diffusion. And that's why the answer for the question is option E, and that is pH 9.2. Thanks for watching.